Alright, so let's get this warm-up done before we start our notes. We have a diagram. This is a review going back to like chapter 1 stuff. So number 1 says name a line that contains point C. Jakai.
Line AC.
Sure, line AC. We would write that with a line over those 2 points that we're using. That's not our only option. You could have called that line CA, line BC, line BA, AB. You have a lot of options on number 1. We cannot. That's a good point. A line we only name with 2 points. Good question. All right, number 2, array with endpoint B that contains point A. We only have one option here. Keon, what do you think it is? So we know it's a ray. What 2 points do you think are going to be on that ray? So when we name rays, we start at the end point, which is B, and we go through the other point. In this case, it's A. On number 3, we need an acute angle with vertex B that contains point C. Shelby, what angle did you come up with? That would be very close, except for that does not contain point C. So,
EBC.
very good. Angle EBC is acute with vertex B and contains point C. If you named that angle CBE, that would also be correct. The last one, a segment with endpoint B that contains point C. Sydney. Segments are named with a bar over the top of them without arrows. We are starting chapter 3. Today we are going to talk about relationships between lines. Our objective is to identify relationships between lines. Alright, our first word is parallel lines. 2 lines that lie in the same plane and do not intersect. I believe we have briefly talked about this already this year. To indicate that lines R and S are parallel, we would write R, this symbol in the middle here that kind of looks like an 11 or a pause symbol. That means parallel. And then S. So R is parallel to S. That's how we would write that or see that written oftentimes in this class. In a diagram, we have a diagram down at the bottom. You can see that these lines do not touch. But the way we know for sure in a diagram that 2 lines are parallel is by using these little arrows they put in the middle. That means that those 2 lines are parallel to each other. So whereas if they were congruent to each other, we use the little dash marks or tick marks. If they are parallel to each other, we use the arrows. In Euclid's Elements, the original geometry textbook from way back in the day, Euclid defines parallel lines as being straight lines which, being in the same plane and being produced indefinitely in both directions, do not meet one another in either direction. Which is just a really, really wordy way of saying 2 lines that do not intersect. Alright, next up we have perpendicular lines. 2 lines that intersect to form a right angle. Usually if they're 2 lines fully crossing each other like you see in the diagram, we actually form 4 right angles, but we'll talk about that more later on. To indicate lines are perpendicular, this is how we name it. R is perpendicular to S. David mentioned this looks like an upside down capital T, and yes it does. That is the symbol that represents perpendicular. And again, we've got a diagram down at the bottom. Those lines cross to form a right angle. They don't have to be vertical and horizontal lines. You can see perpendicular lines that cross each other like this. Also, the important part is that we would still have a right angle. On these examples, we are going to determine if the lines are parallel, parallel, perpendicular, or neither. For letter A, we are looking at lines T and U. So I'm going to trace over those so I can focus on those two lines. Jordan, what do you think? Neither. Okay, these two lines intersect each other, so that means they cannot be parallel. They do not intersect at a right angle, so they're not perpendicular. So T and U would be neither. Very good. All right, let me erase those lines. Next, we are looking at lines S and T. So trace over S and T. Someone else that I have not heard from yet today want to volunteer. David.
Parallel.
They are parallel. Not only do they not touch in the diagram, but they are also marked with those little arrows, which we talked about earlier, that mean that they are in fact parallel. We will move on to letter C, looking at lines R and U. Anybody new want to help us out there? Quentin?
Perpendicular.
Those are perpendicular. They meet at a right angle, so they are perpendicular. Remember, the definition of parallel lines contains two parts. First, they have to be in the same plane. So just because they don't intersect does not mean that they are automatically in the same plane. So first they must be in the same plane, then we make sure they do not intersect. So the next question, what if two lines never intersect but they do not lie in the same plane? How would we refer to those? Alright, skew lines are lines that do not lie in the same plane and they do not intersect. So we're given this diagram of sorts with a tissue box just to represent that this is a three-dimensional idea. Okay, so if we extend one edge going straight up and down, but we come over here to this other plane and go out and backwards, those two red lines that they have there are not in the same plane. Okay, so we've got a line that's in this front plane here. And then we have another line that's on either the top or the side here. Those are two separate planes. Those lines do not intersect. That is why we call them skew. Skew is a little bit harder of an idea to kind of grasp compared to parallel and perpendicular. Again, I don't think this is on your sheet, so it's just remember. Although it looks like the two lines will intersect on your paper, you're looking at a two-dimensional representation of a three-dimensional object. So the lines would not intersect in a three-dimensional space. If we actually brought a tissue box up here with some string or something, we could prove that. Okay, so let's go through these. In this diagram, lines A and B, again, we can always trace over them if that's helpful. It's a little bit trickier with skew lines than it was with parallel and perpendicular because of the whole three-dimensional part. Somebody that I've not heard from yet today want to let me know what they think about part A. So no, as soon as we see that they touch, and they even show the point where those two lines touch, if they intersect each other, they are definitely not skew. All right, part B, we're looking at lines B and C. So I can highlight those lines instead. B and C. Wow, just pulling all the people that aren't here. Martez, skew or not skew? Not skew. Those lines are marked as being parallel. So they do not intersect, but they are in the same plane. So they are not skew. Finally, we are looking at lines A and C, which again, tracing over them is a little bit deceptive in this case, so I don't even know that I would recommend it here. John, skew or not skew? Skew? Yes, they are skew. They are skewed to each other. So line A is poking through the plane. It intersects line B, but it would not actually intersect line C if we had a three-dimensional representation of it. Parallel planes are two planes that do not intersect. For example, in this room, the ceiling and the floor are considered parallel planes. Are there other parallel planes in this room? Yes, like what? The walls. Okay, so not two walls that are right next to each other because those would touch, but walls that are across the room from each other, or these whiteboards that are across the room from each other. Those would be examples of parallel planes. All right, yet another key word, a line perpendicular to a plane is a line that intersects a plane in a point and that is perpendicular to every line in the plane that it intersects, which is really more wordy than the true meaning of it. So if you think about a flagpole stuck in the ground, like in a concrete slab, like out on Central Terrace, a flagpole representing a line is perpendicular to the ground, which would represent the plane. So a line that forms a right angle with a plane. So here's a diagram representing that. I don't know that you have to get this particular diagram copied down, but it helps us visualize it if the flagpole in the ground was not a good visual for you. The red line is perpendicular to the plane, so any line that we have in the plane will be perpendicular to that red line. So we can usually you'll just see like one big box between that line and the plane to represent a 90-degree angle.
So with this,
Part A asks for a plane that appears parallel to plane P. So remember, plane P is the one that has a bold P in the corner. Can anyone raise their hand and tell me what plane is parallel to plane P? Nikitra. Plane Q. Those two planes do not appear to intersect. So the two gray planes do not appear to intersect. Name a line that is perpendicular to plane R. Someone I haven't heard from yet today. Okay. Angel, what do you think? For part B, a line perpendicular to plane R. Line L would be...
did I seriously get that right?
I would disagree with that.
Oh, I was about to say.
I think line L is in plane R.
No, it's
Which one is going up and down through plane R? M. Line M is the one going up and down. Like I said, this diagram's a little bit hard to read, but line L is the one that is in plane R. Line M is the one going up and down through plane R with that little right angle box. Name a line that is skew to line M. So we just talked about line M being right here. Line N would be skew to line M. We'll do it a little differently this time. I'll pull a popsicle stick and you tell me which one you want to answer. If you don't want to tell me which one you want to answer, then I'll pick one for you.
We choose pass.
IKEA. Which of these would you like to answer? Number 9, what'd you get? Plane DEF, very good. So planes A, B, C, and DEF appear to be parallel. So plane D, E, F. All right, next. Julian, which one would you like to answer? All right, what'd you get? Very good. We wanted a line parallel to BC. Line DF is marked as being parallel to BC. Next up, Cade's not here. Joshua, which one would you like to answer? All right, what'd you get? Line DE. Yes, I agree that line DE is skew to BC. And I think that's not necessarily our only option. I think EF would have been another option. And AE would work. Okay, we got a couple options there.
Would BA work?
Would what?
BA.
BA would not be skewed to BC. They have a point in common, B. That means that they cross.
Okay.
We're talking about number 12. We're not going in order. We're letting people pick which one they want to answer. So on number 11, our options would be lines A, B, and DE to be perpendicular to plane AEC. Last one, Kiatha. A line perpendicular to plane ABD. So our options on that one would be like AC or EF.